Howdy team, and welcome to the second video on arrays. And this is the exciting one. This is how we learn how to solve the problem that we were just trying to solve before. Let me just remind you what it was that we were doing. So we were trying to calculate the average temperature, and we had to create a lot of different variables for users to enter temperatures for us to average. And then, so we had to get the user to enter all of them, many, many, many. And then we had to figure out how many of those days were above average. So we had to calculate all of those and on and on. And then finally, we were able to print out the statistics to the user. And that took forever. So I'm going to talk today in this video about how we are going to use this cool new tool called an array to help us save the day, to help us write this program or programs of this type. Okay, so given that problem, wouldn't it be nice if we didn't have to declare all 15 variables at the beginning? We don't know if 15 is too many. We don't know if 15 is too few. So it would be great if we could just declare the number of variables that is exactly what we need. So it would be super nice if we could just say, hey, the operating system, I need 10 doubles, please. I need space for 10 doubles. And the operating system would just be like, hey, sure, let me find you some space. And then in just a second, once that space is found, it's like, got it. You can find your first double right here. And since all of the memory is going to be contiguous, in contiguous what's called words. So a word is the length of an addressable unit in your memory. And we've talked before about how a word is usually a 32-bit or a 64-bit length, depending on your operating system. Usually when you buy a computer, it says this is a 64-bit something something processor. That's what um, that's what we're talking about here, that 64 bits. That's the length of the word. So in this case, we can say, okay, your first double is right here. And then your next double is going to be 64 bits away from that. So you can take this memory address for this corner right here, and you can add 64 bits to it. And then you're going to get your next double, and you're going to add 64 bits to it again, and you can get your next double again and continue doing that up until you get to your last one. This is also convenient because if you know that each index is only 64 bits away from the previous, if you said, oh, hey, I want to get double number 6, or I guess this is in the 7th place, this is index 6, I can just take my memory address, this starting one, and add to it 6 times the length of my word. So that is going to be, if it's 6 times, we have 1 time gets us index 1, 2 times gives us 2, 3 times gives us index 3, 4 times gives us 4, 5 times. And if we add 64 6 times, or we multiply 6 times 64, we get straight to this word. So we can add 6 times our word length to our memory address here and get exactly where we need to go. This is very, very, very fast in memory. So this is super convenient. This sounds like exactly what we need. So let's talk about how we can actually do that, because I know that we're saying, wouldn't it be nice if, but like it's real. We can actually use this. This is a thing. So let's talk about how you create it. So first, you specify your type. I think sometimes it's easier to see it with the example right away. So you specify the type, which in this case is a double. It could just as easily be an int or a Boolean or a string or a custom type of your own. Um, then you give it the variable name. This is the same as any variable name you've written before. Then you use the new keyword. And the new keyword is you asking the operating system, hey, can you make or get me a chunk of memory? So get me a chunk of memory. And then this part, whatever is following the new, tells the operating system how much memory it is that you need. In this case, we need an array. These little brackets here tell the operating system, or tell Java first, that you're looking to build an array. The type here shows you or shows Java that I want to create an array of this type. So make sure that each thing that you give me is large enough to hold, in this case, a double. And a double fits great into a word of 64 bits. So in this case, it is going to create 10. 10 tells us how big our array needs to be. So new knows that it needs to find some memory that is 10 64-bit words long. And then it is going to return the address of the first index. My mouse is a little touchy, sorry. So it's going to find the address of the first index, which is right here. You can think of the address of the very first bit of the very first index. Because what this returns is an address, it's an address to a place in memory. That means that an array is a reference type. So the value here, numbers, is not going to hold exactly the value in memory, like a normal double would. Remember, a double has all of the actual value stored within the bits at that memory address that is used, or that is called in other cases, whatever the variable name is, like numbers is here. Numbers is not storing the value of any double. It is storing the address to the first double in the array. So keep that in mind. And an array is kind of like a pseudo primitive type, but it is not a primitive type in the way that it holds the value inside its own bits. It holds an address inside its own bits. So what have we learned here? A little review. We have the type that we want to do. We give it some brackets to say, hey, yeah, we're creating an array. We're going to call it numbers. Find me some memory that is big enough for 10 doubles. That is what this line is communicating. Let's just stop with the theory. We're going to go back to our program, and I will show you what it looks like to write that program with an array instead of with all of the ridiculous variables that we were using before. Let's talk about it. Okay, so I took our previous program, which was here, and I erased everything that had to do with day 2 or further. So I just kept the things that had to do with day 1. Otherwise, it's completely identical. So you have how many days would you like to average? I only created 1 day. I'm only calculating on the 1 day, and I'm only figuring out if that first day is above average. Again, otherwise it's identical to arrays 1, or the video arrays 1. Okay, so let's talk about it. Here, we know we want to create as many variables as the user specifies. So instead of here creating double 1 day temperature, I'm going to say maybe we want to pluralize temperatures. Okay, and I said that we had to specify to Java that we were going to use an array. So, or we need an array. So we use the square brackets after the type. You can technically put it after the variable too, but that's not great practice. It is better practice to include it here. Notice, you see some brackets up here. That is because args is a string array as well. Fun fact. Okay, so here we're saying, hey, we need an array of doubles. And notice here it's no longer happy with me giving it a constant. We need to now specify. Do you remember what it was? What was it? New. And then we're going to say double again because this is the type. And we need to give it a bracket. I'll put both brackets there. The length is what we need to specify now. And thankfully, the user gave us the length here. So I can say new double, and I'm going to give it the length of days. So this is going to be whatever the user inputs. Now let's just keep going down the line and see how we can fix up this program. So now let's just take a second. This is creating all of the variables for us, all of them in just one line of code. Super convenient. Okay, so now we need to get the temperatures from the user. We have this if statement here, which isn't really relevant anymore, but all of that inside stuff we do still probably want to do. So if there's something that we want to get repetitively and we know exactly how many times we want to do it, that sounds like a loop, right? So what kind of loop do you think would be helpful here? Take a second, think about it. If we know exactly how many times we want to do the loop, we probably want a for loop. So I'm going to say for int, call it day equals 0. I'm starting at 0 here because my index starts at 0 in my array. So I'm starting at 0 here instead of 1 for convenience. You'll see why later. So if it equals 0 and, oh, why did it say day 1 temperature? I just want to call it day. Okay, so then day is less than or equal to, no, we don't want equal to, is less than days, day plus plus. I am getting all confused. Okay, so now this means I am going to loop through every one of the days that we had talked about. Now, we'll talk first reminding you what this loop is going to do, and then I want to change it just a little bit to follow better practices. So this is going to start at day 0, which is going to be the first index into our array. Then we are going to continue looping until we've gone through all of the days, which is going to be all of the indices into the array, all of the indexes. And then we're going to increment in between. Now, our for loop, we know at this point that our array is going to be exactly days long. But in general, we usually don't know exactly how long that's going to be. So it's just safer and it's better practice if you're going to be looping through an array to use the length of that array instead of some other variable that might be modified in between. And I can ask for the length of an array by simply using day temperatures dot length. So what this is going to say, it's going to give me the same value as days, as the days variable would be. But now I'm absolutely sure that it is going to be the same length as day temperatures. So I'm using that here instead of days just for safety. It's kind of irrelevant here, but it's pretty relevant moving forward. Okay, next, we need to print out the prompt to the user. Right now, it's saying day 1, and instead, I want it to print day. So now it's going to say what we want it to say is day 1, day 2, day 3. But keep in mind that day is 0 indexed, and humans usually think not zero index. They think one index or like starting at one. And so because the first day is going to be zero, I'm going to say day plus one, just where we are printing it. We're not going to use day plus one anywhere else. We're just going to make it really easy for the user to understand, and they'll understand better if it starts at one. Okay, so now we are printing. Here, here's where we get the next double from the user. And we have all of these temperatures, or we have all of these doubles in contiguous memory, like we had talked about, and we need to start filling them in. So how exactly do we do that? What does that syntax look like? Let me show you. So we will take our variable day temperatures, and this again is going to be a memory address to the first index. But if we want to reference a specific index within this array, we need to give it brackets again and tell it which index we want to use. So in this case, when day equals zero, we want to reference the 0th element in the array and then store a double in it. So we're saying, hey, whatever the day is from zero all the way up to the count of days that the user gave us, each time I want you to write in that index. So if you remember on the slide, the first index, at index 0, it's going to be printing in here. At index 1, it's going to be printing, or not printing, excuse me. It's going to save the array here, save the array here, save the array here. So this, if you were to write that, would be whatever this array is called. I think we called it numbers. So this would be numbers and then square brackets 2. All right, mouse is being touchy again. Okay, so here we are saying array indexed at day, which is going to take on the values from 0 to days. Scanner equals next double. And then, like we did before, we're going to keep track of the total of temperatures, and we just want to add the same variable that we just created. So here we prompt the user. We are going to save this value into a variable. Just when you're saving a variable inside an array, you have to give it some brackets and an index. No problem. We've created variables before. Then we are going to take that same variable, which is at an array index, and we are going to add its value to the total of temperatures. And now this for loop, this one little for loop, is going to do the same work as, let's see, I'll try to select it all of this. I'm still scrolling. All of this, our one little for loop is able to reduce all of that code. It's pretty incredible. So now we have the temperatures from the user. And we can create or calculate the average temperatures. I'm going to close out all of this here. I'm going to comment out that. And let's run it and make sure that it is calculating the average correctly. Just make sure that everything is running. Okay, I want to move this into a more convenient position. Okay, how many temperatures? I want to enter something simple. Let's do 6. Day 1, see, this is great. We're at index 0, but it's printing day 1. And that I want it to be 80 degrees. Day 2 is going to be 80 degrees. 80 degrees. I'm doing something simple so that we can make sure the average is correct. Then Day 4 is 70 degrees. Day 5 is 70 degrees. Day 6 is 70 degrees. And hopefully our average temp was 75. Exactly. That is exactly what we want to happen. It only asked me for 6 different days and it correctly calculated the average here. Awesome. Okay. Now we don't have to have this comment of fingers crossed they don't want more than 15 because we're able to get exactly the number of temperatures that they want. And that's all the variables we're creating. Okay, so here we're calculating the average. We need to know how many days are above average. All right, I'm going to uncomment this code. All right, now we have this if day 1 temperature is less than average temperature. Let's see. This means that we need again to check every one of the variables that's stored in our array um, to see if they are greater than or less than the average. So if we need to look through all of the variables, anytime you see or you hear the word through, look through, search through, that usually means you need a loop. And usually in terms of array is a for loop because you know exactly how many elements are in that array. So let's loop through again, and we can just use this same format. So I'm going to copy this loop here. Copying and pasting in code is very bad practice. I know that as a software engineer, you copy and paste all the time, but as an instructor, I'm supposed to tell you never to copy and paste code. Do as I say, not as I do. Okay, so I have moved. We're now going to repeat this if statement for every day in our day temperatures array. So in every index. And if what this was before, if that temperature was above the average temperature, we wanted to increment days above average. And so now instead of referencing day 1 temperature, we want to reference our temperature array, which was day temperatures. And in what we just removed was day temperatures, or was the first temperature, but what we really want is whatever index of temperature this is. So I am going to say day temperatures at day. This is a specific variable. Day temperatures is an array, and remember a reference type. All that is a memory address. We need to tell Java and through Java, the operating system, exactly which variable inside that array we're working on. And in that case, it is whatever the index of day is. So we want at first the 0th index or the first element. Then we want the first index, which is the second element, and on and on. So day is going to take on all of those different values and refer to all of those different variables depending on when in the loop or where in the loop we are. We're going to compare it to average temperature, and we can say days above average, nothing else needed to change. All that needed to change was how we were referencing this variable. So now we are able to do this if statement. Instead of repeating it 15 times, we were able to do it 1 time within our for loop here, which is very convenient. Now let's see when we print or when we run this program again. Let's make sure that it is still working. So we're going to enter 6. Day 1's high is 80, 80, 80, and we did 70, 70, 70. Average temp was 75, and 3 of the days were above average. Exactly. That is what we want. Okay, so let's go back to our slides and give just a tad bit more detail. So, okay, when you create an array, the length of the array can be any non-negative integer. It could even be zero, though I'm not sure why you would want to do that. So it can be any non-negative integer. You cannot create an array of a negative length. Like you can't have a negative length. That's not a thing. So you could have an expression, something like this. It can be something calculated. It can be a variable name. It can be a raw number. It can be whatever this expression is, so long as it evaluates to a non-negative integer, everything's going to be fine. And it's going to create an array of that length. In this case, we are creating an integer array instead of a double array like we've seen before. And when an array is created, every cell inside the array, every word is going to be filled with a zero equivalent value. So if you were to have an array of ints, each of those are going to be initialized to zero. If you're going to have an array of doubles, each of those are going to be initialized to 0.0. If you have Booleans, it's going to be false is what's going to be filled. False is the equivalent of zero for a Boolean. And then we have string or really any other reference type. It is going to default to null or empty. So this is something to keep in mind because if you are going to do some sort of calculation on the ints that are stored there, maybe this zero is a valid value and it's okay to never touch that variable and have it still have a zero and it's not going to hurt anything. But maybe that zero is going to impact your calculation. So you would have to be very sure that that zero is acceptable. Otherwise, you'll be very sure that you've touched every element in the array to give it some value other than zero, if that's what you need it to do. Same with doubles. It is not, you are not going to see an error if you try to, even just after creating it, just after this, for example, if you want to print it out, it's going to print out all zeros. It's not going to say, hey, you haven't given me a value yet. It's going to be like, yay, great, it's a zero. Maybe that's good. Maybe that's not good. It's just something to keep in mind. If you tried to print out all of the strings, you would just get null, 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 null. Um, so that's going to be more what you would expect. You haven't put anything there, so it doesn't hold anything there. Not the same for your primitive types. The primitive types are going to get a zero equivalent. Okay, you can have arrays of whatever types you want. We've got doubles here. You can index into an array. That's another way of saying like you want to go to the variable at an index with the square brackets. So I'm going to index into the array at 2 and set it to 3.4. I'm going to index into the array at 4 and give it negative 0.5. And our values are going to look like this. We've got 0.0 because that is what is defined by default, even though we haven't added those variables or even talked about it, they have a zero value. I mean, talk to Java about it. And the ones that were specific have their values now. That's what the memory would look like. You can have Booleans, and it would look something like this. We create new Booleans. They're all default to false. We set tests at 3 or indexed at 3 to true, and it is going to look like this. Okay, take a second. Think about this question. What is going to be output by the following code? Let's take a second and run it. What do you think the odds are that this is going to copy right the first time? I don't know. Let's see. I don't know. It's not formatting for me, but Let's run it and see what happens. Errors exist. What is your error, sir? My compiler is a sir, apparently. You tell me. All right. It is not happy. All right. Anyway, let's talk about it. We have the answer here is going to be a runtime exception. It's going to be what's called a null pointer. So here we've created an array that holds five different strings in it. And remember, what's stored at a string variable is the address to that variable in memory. So we're going to have our array is going to hold five different words where each word is going to hold a memory address. Here we are setting memory address or index one within that array to Olivia, index three. Okay, this touchy mouse is getting on my nerves. Okay, we've set index three to Isabel, and then we're printing out names.0. If you remember, names is going to be a string array, and a string array sets all of its elements to null by default. So at this point, index 0, 2, and 4 are still going to be null. We cannot take the length of a null variable, and therefore this is going to be an error. And it's going to happen at runtime because there's no way for us to figure out at compile time that there's something that's going to be wrong. Java is just not smart enough to conceptually understand that we haven't set that variable yet. So the compiler is not going to catch that that's an error, but our code will crash with what's called a null pointer error. That just means that the address, it's expecting an address to be stored there, but it found null instead. So it can't find the string. It's just null. It doesn't exist. So fun, fun with arrays. All right, team. Thank you for enjoying this video with me. The next video, we'll talk just a little bit more detail about arrays and how they work. And I will see you in that video in just a bit. Thanks, team.